Model description. The regional climate model used in this study is the ICTP RegCM4 described by Georgi et al. It is a hydrostatic model based on the dynamical core of the Penn State/NCAR mesoscale model version 4 with the developments described by Georgi et al. RegCM4 includes a range of physics options, and for the present work, it uses the radiation scheme of Community Climate Model version 3, CCM3, the non-local planetary boundary layer scheme originally developed by Holzlag et al. And later modified as described by Georgi et al. The biosphere-atmosphere transfer scheme is used for land surface process calculations. Precipitation is represented by two different terms, resolvable, large-scale non-convective, and convective, subgrid cumulus. The resolvable scale precipitation is represented by the subgrid explicit moisture scheme. For convective precipitation, three options are available: 1. The modified Andesquo scheme, 2. The Grell scheme, and 3. The Emanuel scheme. In addition, different schemes can be chosen for land and ocean regions. After many preliminary tests, we selected the Grell scheme with a Fritsch-Chappel closure over land and the Emanuel scheme over the ocean grid points. More information on the different physics schemes and applications of the RegCM4 model system can be found in the study of Georgi et al. The simulation/analysis period is 1982 to 2009, and we applied similar experimental setup with previous study, in which, its initial and lateral boundary conditions are obtained from the new ERA interim 1.5 degrees times 1.5 degrees third generation ECM-WF gridded reanalysis product. The sea surface temperature, SSD, used to force RegCM4 is obtained from the National Oceanic and Atmospheric Administration, NOAA, weekly optimum interpolation, WKOI, on 1 degree grid. The 10-minute resolution global land cover characterization, GLCC, dataset for vegetation cover, land use and elevation is used as obtained from the United States Geological Survey, USGS. The model domain, the upper right panel, covers most of the African continent and adjacent ocean waters at a grid point spacing of 50 kilometers. This study showed that this domain size is sufficient to obtain a realistic simulation of the climate of Ubnabur. Topography, in meters, of the study area. The blue lines are the 14 homogeneous rainfall regions. The red dots represent the rainfall stations used in this study.